Seismological instruments. In the seismology room, the first object that you come to is a clock. Time is the first quantity that is necessary in seismology. Since October 1884, time has been measured on the Greenwich meridian. The seismographs on display on the right side of the room are mechanical instruments designed by the German physicist Weikert at the beginning of the 20th century. These instruments were very innovative for their time. The first is a seismograph of 80 kilos for the vertical component, while the second is a seismograph of 200 kilos for the horizontal components. They were constructed in the workshops of the Istituto Nazionale di Geofisica during the 1950s. Such instruments were particularly suitable for the recording and study of strong earthquakes that were close by. At the end of the room on the left-hand side, there is a recorder with thermal sensitive paper for a seismograph situated in the basement below, away from anthropic noise. On the shelf on the left, there is a seismograph inside a transparent container, like the one in operation on the floor below, which is currently recording. On the same shelf, there is an electromechanical seismograph with photographic recording. This instrument is linked with a galvanometer situated on the table of the gallery level. If you lean gently on the shelf, it produces a light movement of the seismograph coils, which as they move, produce an induced current. A galvanometer transforms the current produced by the seismograph back into movement and provides a representation of it on the seismogram on the wall. On the same shelf, we can also see Luigi Fascinelli's earthquake warning system, consisting of an inverted pendulum formed from a sphere placed at the top of a steel rod. A rod emerges from the center of the pendulum, surrounded by 4 steel bands. In the event of an earthquake, the loss of balance causes contact between the bands and the rod, closing an electric circuit that activates a sound alarm warning that the earthquake is in process. After passing the table, there is an exhibit which is useful for understanding the order of magnitude of earthquakes. If you push the panel, the measure of energy created by the push appears on a display. Turning left, you will see a seismograph constructed by the Japanese scientist Ishimoto in 1933. The advantage of this new instrument was that it was small and light. It weighed only a few score kilos and was quick to install and highly sensitive so that it could be used for studying smaller seismic areas. The other object on display is a lamp with a toluene diffuser to make the soot-covered paper used for mechanical recording and a trestle for fixing the soot with lacquer. We will now go up to the gallery level by the stairs opposite the door of the octagonal room, or going backwards toward the entrance by the main stairs.